Hello everyone, how are you doing today? How do you like this channel and its content till now? Please comment your thoughts. Today, I have got one interesting topic to share with you folks. From today, I will introduce Terraform with AWS. Terraform is a HashiCorp language mainly used to provision infrastructure as code. This is a very powerful tool for many cloud providers. It is very easy to write and very easy to learn. In this part, we will discuss how can we provision one S3 bucket with Terraform. This is just an introduction. Gradually, we will move to more interesting topics like Terraform state, Terraform state manager, Terraform environments, Terraform modules, and many more. I will mainly show you how to create most used AWS services with Terraform and how to provision and manage them. What are the different issues that we face in an enterprise? So hold tight and enjoy. If you are new to this channel, kindly like, share, comment and subscribe. Let me know how do you feel about the content and what do you want to watch more. So let's go and check out the tutorial. So welcome to this tutorial. And first of all, I will show you what is Terraform, why do we need it, in a sliding view. Next, we will go to the practical section where we will do everything from scratch. We will build one S3 bucket and from scratch. So the first question is, what is Terraform? So Terraform is an infrastructure as code or a language to provision infrastructure as code. There are other infrastructure as code available in the market as well, like AWS CDK, CloudFormation, and Terraform is one of them. The easiest way of Terraform or the usefulness of Terraform is that it is multi-cloud. That means Terraform is not only available for AWS, it is available for Azure, it is available for Google Cloud and many more. So Terraform is very robust and vast. So to give a gist, like what is Terraform? Terraform is an infrastructure as code to manage our infrastructure with a language. So next, let's go to the next slide, and then then I will discuss why Terraform. So why should we use Terraform? We have CloudFormation, we have AWS CDK, but what makes us Terraform is special. So I will mainly focus on most of the 5 benefits of Terraform that is mainly used or that is mainly talked about. So the first one is improve multi-cloud infrastructure deployment. What does it mean? So Terraform applies to multi-cloud scenarios where similar infrastructure is deployed on Azure, maybe Google Cloud or local data centers. Developers can use the same tool and configuration files to simultaneously manage and resources of different cloud providers. Next is automated infrastructure management. That means Terraform can create configuration file templates to define, provision, and configure AWS resources in a repeatable and predictable manner, reducing the deployment and management errors resulting from human intervention. So it is automated. So the human intervention is reduced. In addition, Terraform can deploy the same template multiple times to create the same development, test, and production environment. So this is automated. Next one is infrastructure as code. This is the main point. So with Terraform, you can use code to manage and maintain resources. It allows you to store the infrastructure status so that you can track the changes in different components of the system and share those configurations with others. Also, another very important point is the reduced development cost. You can reduce the cost by creating on-demand development and deployment environments. In addition, you can evaluate such environments before making system changes, like the testing. And also, the last but not the least is reduced time to provision. Traditional, like if we do with the management console, the organization takes days, like even weeks, and might be a human intervention is there, so it is error prone. With Terraform, full deployment can take in minutes. Just a few clicks or keyboard pressing. For example, you can provision multiple AWS resources at any time in a standardized way. Both brand new deployments and migrations can be done quickly and efficiently. So this is the main 5 benefits of Terraform. Why should we use it? Now next move on. So the next part is, okay, I know what Terraform is, I know why should we use it. So how can we use it? So in this part, I have mainly focused on the mostly used commands of Terraform. So first of all, in Terraform, when we will create the infrastructure as code, we need Terraform in it. So this command is very much important. It initializes the Terraform and its module and its providers as well. After that, we have a very good Terraform code validation command, which calls Terraform validate. It will validate our syntax and see if everything is correct or not. This is not mandatory because when we will do Terraform plan anyway, it will validate again, but we can do it. So after that, we will do Terraform plan. Terraform plan is also nice way to see what plan will be executed. And the next one is Terraform apply. So Terraform apply command applies the infrastructure for provisioning. So mainly these 5 commands we will use focusing on our infrastructure provisioning. Sometimes the provision or the sometimes there is some critical things are required like the state management, which will be covered in a next topic or next tutorial. We need Terraform refresh. Then the state refresh is needed. Terraform push, the state pushing is required. There is another statement which is not here, which we often use, is called Terraform state pull. Sometimes we need to pull the state from remote to our local. Terraform taint, untaint, lots of commands are there, but those are not so much frequently used. One of the major command is again Terraform destroy, to destroy the fully provisioned environment. Okay, so these are the main commands that we will be using in our Terraform environment. Next is Terraform steps. So what are the steps included in provisioning or infrastructure provision? So this is a nice graph that I have given here. Is that suppose we are the practitioner or we are the developer and we have written infrastructure as code using Terraform language. And the next part is to plan the infrastructure as code. That means we have to we have to plan what we will deploy in our environment, whether it is development, production, QA, anything. So in plan, there is the command Terraform plan, and it will give me an overview. Hey, I am going to deploy this resources to this environment. So this is plan. And after that, if we are satisfied with the plan, then we can apply. So upon applying, the command is Terraform apply. Upon applying, it will apply to the cloud provider that we will be validating. Like it may be AWS, it may be Google Cloud, it may be Microsoft Azure as well. And when the apply is done, it will provision the resources to our cloud. That means it can create one EC2 instance, it can create one S3 bucket, or whatever we are asked him to create it in the plan itself, then it will apply the same into the cloud. So this is the overall steps. So the next part is the main agenda of this tutorial is create an S3 bucket with Terraform. This is a very simple Terraform use case to create an S3 bucket. As this is a introduction video of Terraform, so I have made it very simple that how we will create an S3 bucket with Terraform. So let's go and check out our demo. So to start with, I have used this management console here open. So I will provision every infrastructure as code in this management console. And also I have opened the documentation from Terraform. That is the official documentation of Terraform. So I will give the link in the description box. Please check them out. And also the code base that I will be using, I will also give the URL in the description box. Please check that out. So if you go to this one this URL registry.terraform.io, if we go to the HashiCorp one, we see that there are multiple cloud providers involved. There are AWS. So there are AWS, there are Google Cloud, there are Azure, Kubernetes, and everything is there. So we will be mainly focusing on AWS. That's why I have clicked on AWS. And in AWS, if you come here, it will show that what are the main things it can be done here with this provisioning thing, or what help we can get it here. This is an overview. This will also tell you which version of this provider is currently on. Currently it is 4.62.0 and it is published 5 days ago. And the main documentation part is here. When you click on this documentation, and here it will show you how to use this provider, how to authenticate, and everything it will show. Suppose we are mainly interested in the bucket. So if we type in bucket, it will give you all the resources here on the left hand side. That so mainly on the resources section, if you see S3, that S3 is a bucket. So if you click on this S3 and then AWS S3 bucket, it will show you, it will give you one template like how can we use this and provision one S3 bucket. So this is very simple. The documentation is very nice. We actually get very much help with this documentation. So this documentation is very nice. This is fine. And so the documentation is ready. My management console is also open. If I go to currently in the S3 section, we will be able to see there are no buckets. Currently there is no buckets. So what I will do, I will open empty repository with PyCharm. So I have created one Terraform folder and opened that folder with PyCharm. You can use any IDE if you want to use. If you want to use VS Code, that is also fine, or any other IDE of your choice. So I have used here PyCharm, and also I have one plugin installed for Terraform, so that I will be using. So mainly I have created one empty folder Terraform, and within that I have opened that folder with PyCharm. So nothing fancy. What I will do now is provision some resources, and before provisioning I will create a couple of Terraform files and I will explain why I am creating it. So the first file I will create is called provider. So the provider means we have to tell Terraform, or we have to tell it that we will use this provider, and my access key and secret key and region will be provided by the provider, and we also have to give the provider version that it is required. So for that we need to create one provider.tf file. So I will give it a name called provider.tf. So this is my provider.tf, and in this provider.tf we will mention that we need this provider. Which provider we need? So for provider we need AWS. So these are the provider that is there. So on that I will mainly choose AWS, and this is not mandatory to give everything here, but still we will give something here. Because the provider in AWS, if you select AWS configure, or if you do AWS configure in your terminal, it requires mainly 3 components: the access key, the secret key, and the region. So these are the 3 things AWS required for configuring your environment. So this is the same thing we will give here in this provider section. So first of all we will give region, and the region is where dot AWS underscore region. This is fine. So what, where, do not bother about it right now. So I will explain it later. So first of all we will provide region, and then we will provide access key. I will also take it from variable. So I will give where dot AWS underscore access underscore key, and the next is secret key. Secret key also I will take it from variable AWS underscore secret. So I am telling that my provider is AWS, and for that provider the configuration is this, the region is this, the access key, secret key is this. Apart from that, we have to also specify the Terraform required version for the provider. So for that, what we need to do, we need to give it Terraform, and for that we have this command called required providers. So Terraform have a required providers, and the provider name is AWS. And which version we need from that provider? The version is mainly we will use. So the version mainly we will use greater than 4. So if we see the documentation here, the one that I showed you currently, if we see the documentation here, if we come to the first page here in the AWS, if we see that the version is 4.62.0, that means greater than 4. So we need to use, we want this version. So as soon as we mention that we need greater than 4, so it will grab the particular version and it will use that documentation. And we have to mention the source. What source? We will use HashiCorp, that is HashiCorp Terraform. So we will use HashiCorp Terraform, and from HashiCorp we need to use AWS, and for AWS the version is greater than 4. This is the required Terraform provider. If we use Azure, we have to specify Azure and its version here. And also for the configuration what Azure needs, the configuration will go here. Now this is my provider part. So my provider is ready. Now what about this? So why it is getting error? So in Terraform we can give, or we can supply the values from a variable. So we can hold a particular value in variable, and from that variable we can take the value whenever is needed. So for that we need to give one file called var or variable.tf. So let me create one file called variable. So this is my variable file. So here we will provide the variables here that is needed, and we will give a default value to them. So let's give that. So this is my variable.tf file, that is the vars.tf. You can mention any kind of name here, just this part is mainly required. So what is this? So this is my variable file. We can define any kind of variable here, and later we can use the variables in our code. So what we have defined here is that variable AWS region. So AWS region is required, and the default value for the AWS region is US East 1. If we do not provide any other value, it will take US East 1, and the type is string. This is also not mandatory, you can give it. And the another variable we will define is AWS secret key, and another variable is AWS access key. So this is the variable that we will define, and we can use the variable throughout our code. This is the main funda of using variable, like the variable that we use in any other programming languages like Python, like Java or anything. So as soon as I declare the variables here, we see that the error is gone in our provider. So the provider knows that we are taking the variable here, this called var AWS region. That means this is the variable it is taking. So it will take US East 1. And if I provide that var.aws access key, that means it will take from my variable file the access key. But check that out, that we have not defined anything with access key value, because it is not recommended to hard code our access key and secret key here in this variable file. So we will provide it dynamically during our deployment. So this is why we have not done that. So if there is no variable given as a default value, it will ask me at the time of deployment or plan, hey, I don't find any default value, do you want to provide one? So I will then can give the access key and secret key. Later on in this tutorial, I will show you another way of providing the variable value there, which we mainly use for our local development, but we do not give them, or we do not push the code to GitHub with that. So for that, we will create another file, but that comes later. So anyway, our provider and our vars component is ready. That means our Terraform workspace is kind of ready, but it needs some more work. So let's see what work is needed. So the main part is pending is the resources. So right now, if we do Terraform initialization, it will check if there is any resource to provision, or it will just bootstrap the environment. So what we will do, I will open the terminal now. And as soon as I open the terminal, and I will configure my AWS access key and secret key in the terminal, and let's do a Terraform, and let's initialize this workspace first. So this is my workspace, And this workspace I have opened up with terminal. If I type in Terraform here, you will see that lots of Terraform commands it will give, like what we need to do, the main commands: init, validate, plan, apply, destroy. So these are the main commands. Apart from that, we have other commands as well, and it will show you. But anyway, we are not interested in all of those. So I have cleared the screen. So the first thing we need to do, we need to configure our AWS credentials. So how to do that? So for that, we need to use AWS configure, and it will ask me for access key ID, which is this one. And then it will ask me for secret access key ID, which is this one. And then the default region I will leave as it is, and then everything is set up. So my AWS configuration is done. So my local AWS configuration is done. So I will again clear the screen, and then if we see here, we have mentioned that our provider is AWS, and the Terraform required version is there. The AWS version is also required provider version is also given. What I want to do now, I want to initialize my environment. So how to do that? So for that, we have this command called Terraform init. So as soon as I give it, and it will initialize the environment for me. So you know what? Before that, we can do one thing. We can do Terraform FMT. This is another command. So this will format my code according to Terraform standards. So let's see if it formats anything. So Terraform FMT, if I give that, so it found two Terraform file, provider.tf and vars.tf, that is to our two file, and it has formatted that with the actual formatting done in Terraform. Like, I don't know what it actually did, but I'm not sure. Anyway, so it formatted the code the standard way that Terraform recognizes it. So it will give some indent here. The all the equal signs are on same order, like that. So it will format our code, like it will make the code looks much beautiful. That it will do. So after that, we will do Terraform init. So Terraform init will initialize our environment with the required provider. Terraform init also initialize the module that will be there in the Terraform. So for that, we need Terraform init. So as soon as I give Terraform init, you see it is actually finding the HashiCorp AWS version matching greater than 4. That is 4.62 that we have seen. This is the latest one, and it is installing the HashiCorp version 4.62, and it has created one log file that this Terraform initialization has been done, and Terraform log file has been created. So as you can see here, it said that Terraform log file, why it is required. So it is required that it will capture our current provider version and the current provider selection as well, and it will make that environment available on the next time we will do any initialization call. So it will not every time install the plugins for us. So this is why the log file is very much important and it is needed. And also it says that Terraform has been successfully initialized. That means Terraform init has been done. So this initialization and the provider version, it has found all the plugins, and it has initialized everything. So this is nice. We will clear the screen. After the Terraform initialization is done, we will do another round of check with validate. So what validate does? Validate actually validates all the code that we have written down, if it is in correct format or not. As I said, Terraform validate is not mandatory. So if I give Terraform validate here, it will validate all the configuration if it is valid or not. But Terraform validate is also included in the Terraform plan. So as soon as we do Terraform plan, it will anyway validate the code for us, and it will show me the plan. So right now the next command is Terraform plan. So it will show me all the plan that will be triggered, or if any resource it has to provision or not. So if I hit enter, so it is asking me for an access key. So as I said, why it is asking me? Because in the variable section here, we have not mentioned any default value for access key or secret key. So it will ask me for access key and secret key every time I will do initialize, or in every time I will do plan or deploy. So I have to give access key here. So this is my access key, and it will again ask me for secret key, and this is my secret key. As soon as I hit enter, so we see that no changes. That means our infrastructure matches no configuration, because we don't have anything to provision. So that means our Terraform plan is showing up that our no resource is to create. So this is fine. We don't have any resource right now. Now let's go back to our workspace and provision actually some resources. Now before moving further, I'm very much annoyed about every time asking me about this access key and secret key, right? So for that, so if we don't want to provide any default value for our variables, what we can do, we can create one Terraform variable file. So this is called, Terraform vars. So this file we will create. That means this is a variable file, Terraform variable file, and within that we will give this access key and secret key. So for that, we have to copy this one, and the main context is like this: access key we will give, and another part is so we will give like this, and then the secret key. So this is my secret key and this. So now let's paste our access key and secret key here. So I have pasted my access key and secret key here. So as after that, if I do Terraform plan or Terraform apply, it will not every time ask me for my access key and secret key. So it will come here in the variable, and in variable it say that my access key and secret key are a variable, and is there any variable defined for this one or variable input defined for this one? We can define this in Terraform variable file, that is tfvar. Now, important thing to remember, do not do this kind of infrastructure or this kind of coding in production. In production, every time if you need access key and secret key, it should come from either HashiCorp Vault. You can put your access key and secret key in the HashiCorp Vault, or you can put your access key and secret key in the GitHub repository or GitHub actions, GitHub settings, so that it is not exposed with everyone, your access key and secret key. So this is not at all recommended in the production environment. So as this is for local development, we can give the access key and secret key here like this. So this is fine. Now the main part. What is the main part is the resource provisioning. So to provision the resource, we need to create one Terraform file. The file, I will give it name as main.tf. In the main.tf file, we will provision S3 bucket. So how should we do that? So in my opinion, I will do it using a module. So what is module? So module is kind of set of Terraform configuration file for a single directory. So suppose we want to create one S3 bucket, right? And for S3 bucket, we will not give the entire S3 bucket code here in our main file. What we can do, we can create one module and put that S3 bucket module there. So for that, if we want to create one EC2 instance, we put EC2 instance module there. If we want to create one ECS cluster, we put ECS cluster code base into that module. So our main code is kind of clean and it is reusable. So the main funda of module is to have our code not tightly coupled. So if we give a module name, like if we want to use if we want to provision S3 bucket, we will give the module name like S3 bucket or create S3 bucket. Then we can just import the module and reuse the code of that S3 bucket module. So module can be done in two different way in Terraform. One is locally provisioned module. That means the code of that module is locally available, that is available in our workspace. Or we can do it remote module. So remote means we have to give one URL and from that URL we will export the modules from other repository like from GitHub or anywhere else. So this is the main funda of module. So to module is nothing but creating a folder. So let's create a folder for module. So as we are creating S3 bucket, we will give the name called Terraform, then the provider name, and then S3. So this is my module. This is my Terraform S3 bucket module. And within that module, we will create one file called bucket. So because this is S3 is a bucket, so we will provision our S3 in the bucket.tf here in the bucket.tf. So this is the place where our main code will go for the bucket. So how to create one resource here. So this is the main part where we will provision the resource. So to create one resource in Terraform, we need this tag called resource, and then we need to give this resource like what type of resource it is. So this resource is an AWS S3 bucket resource, and we need one identifier. So this is a logical identifier for a Terraform or to AWS to manage the resources. So for that, we will give the name as bucket, then the channel name. So this is my logical ID of the bucket. So we are saying that create this AWS S3 bucket, this resource. This is the main code for Terraform. And inside that, there are a couple of mandatory variable that we have to give, or mandatory argument that we have to give. So to create a bucket, the first argument or the only mandatory argument is that the bucket name. So if we create, just remember this one or just compare this one with the management console. So if we are in the management console and if we want to create the bucket, all we have to give is the bucket name here. Nothing else is required, right? So we can give the bucket name and that's it. So to give the bucket name, there is an argument called bucket, and within that bucket, we need to give our bucket name. So we will give demo bucket. So I have just given that because it should be unique one. So this is a unique bucket. So this is my bucket name, and this is the main part, and this is the main block where an S3 bucket will be created. Nothing else is required in Terraform. Now, if you see that this bucket.tf or the resource is under this Terraform AWS S3 module, right? And we need to tell Terraform that take this module and create the infrastructure. How can we do that? So we can do that in main.tf here in the main file. So in main file, we can refer this module and say that boss, go to this Terraform AWS S3 module and take that bucket.tf and create the resources. Simple. So how can we tell our Terraform that to look for the main.tf? So this is very simple. All we have to give is module here. This is the tag. As we give module, and we have to give one logical name here. We will give S3 bucket as the name. And where is the source? So I am saying that there is a module of S3 bucket and the source is Terraform AWS S3. So for that, as I am in the same level of the Terraform in this folder, so we have to give like / and then Terraform AWS S3. So I am saying, hey Terraform, go to this module and you will find the module in the same directory structure, and from that take the bucket.tf. We don't have to specify that one, take bucket.tf. So it will go inside the module, it will this source and take the module and create the resources. That's it. This is the funda of module, and we don't have to do anything else. So what we have done till now, we have created one Terraform variable file, which is this one, and we have given our access key and secret key, just not to give every time here. This is not mandatory one. You can do it for your own purpose. And we have defined one main part where we are creating one S3 bucket, and from where the module is, this is the module code that it will create one S3 bucket. Fine. My Terraform code is done. That this is all you need to provision one S3 bucket. What we can do here, we can go here in our terminal and run Terraform fmt just to format our code. Let's see. So it formatted our tf vars somehow. Then we have to give Terraform init. Why? Because we have to again initialize our Terraform workspace. That means it will validate everything, and it will initialize. It will also bootstrap the S3 bucket that we have asked him to do, and then it will also install this module here, because whenever we will create one module, the module installation is only done by this init command. So after we give it, I will give enter, it will install the module. So S3 bucket initializing the module, that means the module is now installed. This is initialized. Now we will clear the screen, and then what we will do, we will do Terraform plan. So as soon as I give Terraform plan, it will show me what are the plan it is actually trying to do. So you see here plan, 1 resource to add, 0 change, 0 to destroy, and it will show here what plan it has created. So the plan is to create, and what it will create, it will create one S3 bucket, AWS S3 bucket it will create. And for that, these are all the argument that we can pass, but we have only passed the bucket name, that is this one. And force destroy is false, that this also we can pass. So whenever we will do Terraform destroy, it will automatically destroy the bucket. With this one we did not give, but maybe we can give it. Let's give it a try, and we will give it now. So the default value is false. We can do it true. So these are the plan. So this will show me that this is the plan that it will apply. So before applying, let's again change this one in the bucket, and I will give force destroy as true. That's it. Now let's go back to our terminal, clear the screen. We will initialize one, or we will format first. Then we will initialize one more time. This is not required, but anyway we will do it. And now we will do Terraform plan. This time what I will do, I will take an output of the plan and make it as terraform.out file. We can take the plan output in a file. So the command is I am saying that please take the plan out and print it in a plan.txt file. So it will not show me the plan here in the console. Rather, it has created one plan.txt, and if I open this one, we see here this is the same plan. So this is the escape characters. This is the same plan that it has, and it will create one S3 bucket and S3 bucket, and it will only and if you see here, this is the force destroy. This part is true now, and this is the same bucket. So one to add. If we want to see it here, it will again show me the same thing in a readable format without the escape characters. It will show that force destroy equals to true, and this is the bucket name and one to add. This is fine. This is all we need. Now, how to apply this one? So to apply or to provision infrastructure, we need this command called Terraform apply. So as soon as we give Terraform apply, it will take the plan. So here it will take the plan, whatever it has planned before, and from that it will provision the resources in our cloud management console. Now, one more thing that I wanted to show you is that the initialization. Whenever we have done Terraform initialization here, two things has been created, one for provider and one for modules. If we see the module, it is this one, this module JSON has been created, and it only shows that from where it is taking the module. This is the one, and inside the provider, it has also created one Terraform provider, that is this is the HashiCorp. From their AWS, the version is 4.62, and this is for Darwin AMD, the installation version it will show for the local environment, and this is the file for the provider. So this is created whenever we do Terraform initialization. Fine. Now please check out the files here properly. We see that there are only vars, tf vars, provider, main. This is our output, Terraform log file, and module and .terraform. There are no other files. Now see the magic here. Whenever we will do Terraform apply, so it will show me that this is the plan, and one to add, that means one S3 bucket to add. Do you really want to perform the action? We have to specify yes. As soon as I press specify yes, first of all, let's go back to our workspace, and we see that one Terraform state has been created. So what is this? Terraform.tf state. What is this? So if I open this one, we see that one serial number, that is this one, is the first serial number. First serial has been created, and this state shows that what it will actually do, or what is the current state of my AWS cloud environment. So the current state is I have only one resource deployed, that is the S3 bucket, and the bucket name is this one. The provider is HashiCorp AWS, and these are the attribute of the bucket, nothing else. So it will show me the details of the resources that it will provision, and it will hold the state in my local. As we have not given the state, or as we have not maintained the state remotely, this will be maintained locally. I will show in my next video how can we maintain the Terraform state in remotely in AWS. How can we maintain the state in S3 bucket? So this state file actually very much important, and it is very widely used, that whenever suppose we are provisioning one resource, we are provisioning one S3 resource in our AWS cloud, and we want to manage the state, or we want to see that what is the current state of the AWS resource, AWS environment. What are the resources that has been deployed? What are the resources that has been removed? So for that, this state file is very much needed. So it holds, this is the single source of truth about your infrastructure provisioning. So whatever resources are there inside the resource section, it will manage, the Terraform will manage the resources from this state file. If the resources is not there in the state file, Terraform will not manage that particular resources in our management console. So this is very much important, and this is a single place of truth, or single source of truth about all our resources. If you see here, this will show all the attributes for my bucket. The tags are there, timeouts, website configuration, and everything. Here the logging information, lifecycle rule, ID, and everything is there. So that means, and it has only one resources there. That means one S3 bucket is created. So this state file is very much important, and please check out the serial number. Whenever the first time it will be created, the serial will be 1. So this is about state file. We will go more with Terraform state file in our next videos. So I can see here in the meantime that the apply complete and resource 1 added. So let's go to our management console and see if the bucket is created. So we see here the bucket is created. This is the bucket, demo bucket beyond the cloud, and nothing is there. No properties has been changed, nothing is there, no permission has been modified. So my bucket is created. Now one thing I wanted to show you, that here it says that objects can be public. So how, but this is not a good solution, right? Objects can be public. So if we go here in the permission section, that block all public access currently off. So we want to do that. So this is our next experiment. So we have the bucket. How can we make changes or to our resources? So let's do that. So to do that, we have one component, and the component is AWS underscore S3, not the account but the bucket public access block. So I will type in bucket. I don't see it is coming here. Security bucket public access block. So this is the one. So this property actually tell me that please block the public access setting for the bucket, and I need to give one logical ID for this, and for that I need to give public access block, and then we need to give some code here. So the mandatory version here is the bucket, and for that we need to give we need to refer to this bucket. So how can we refer another resource in this particular resource? So how can we do that? So to do that, we need to type in this one. So which type of reference it is? It is an AWS S3 bucket. And which bucket is it is this one, bucket beyond the cloud. This one is we are referring to, and what we are referring to is the ID. That means the bucket ID we are referring to. So this property actually holds true for this bucket. So this is my bucket. That means this one. And what property actually we will give? We will give block public ACLs equals to true. Not all true. This autofilling sometime is very annoying. Then block public policy is true. Then ignore public ACL is true, and then we have restrict public bucket is true. That's it. So if we give this 4 property, our bucket will be private. Now fine, what we will do again, the same thing. We will do Terraform FMT, format our code. Our code is now formatted, and what we can give here is Terraform validate. So my configuration is valid. We can give Terraform plan. Now we can see what has been changed. Now, very interesting fact. What we can see here, we see that it is refreshing the state. Which state? That is our local state. Why? Because the module S3 bucket has some changes. What changes is this? This is the 4 property that it changed, and the bucket, the ID is fine. This is the logical ID, and this property, this one, this 2, and this 2. So these 2 are changing, and changing for which one? Changing for this particular bucket. So this is very much important to know that after a change how Terraform behaves. Whenever we will do Terraform plan, it will refresh the remote state. It will compare the state file to the plan that it has generated now to the state currently it will apply now, and it will give the differences. So the differences is that it will give this 4 property to this bucket. Now we will again clear the screen, and we will do Terraform apply. As soon as I give Terraform apply, it will again ask me for validation. Yes. So if you really want to apply this one, I will put in yes. And as soon as I give this, it says that module this one public block is creating, and the association is also kind of done. Now, very important thing is that I wanted to show is here the TF state. So what happened to our Terraform state? If we open the TF state, we see that the serial has been changed. Why? Because it has now, we have modified the state file. So the previous state file has been backed up with this one. This is the previous state file where it says that the serial one. So this is the original state file. It will hold the backup and it will create a new state file saying that this is the resources that has been provisioned currently, and this is the current state of our infrastructure, or this is the current state of our cloud provisioning services or our AWS console. Important part to see it here in the instances part. In the instances section, if we see that attributes have currently value, the block public ACL true, bucket is this one, ID is this, and ignored public ACL restrict public bucket is there. If we open the bucket backup, we see here the instances. We see here module instances. This is for my main bucket, and now this part module, this resources, this part is created for our newly created public access block. So this is the main difference that happened after provisioning or after applying. So this is why the state file has been modified, and this is the current state file with the serial number 3 and the backup state file with the serial number of 1. This is fine. Now if we go back to our management console and if we refresh this one, we see that right now buckets and objects are not public. If we go inside the bucket and the permission, we see that block public access has been enabled. This is fine. Now my resource has been created and I have also applied everything. So Terraform plan command we have used, Terraform initialization we have used, Terraform apply we have used. The last important part is how to destroy the provision resources. So to destroy that, we have this command Terraform destroy. So as soon as we give this one, it will ask me for an approval and it will say that I am going to destroy this particular resource from your AWS environment. And how it will find it? It will find it from our state file, that these are the main resources that is currently managed by Terraform, and it will try to destroy this one. And as soon as I give yes, it will destroy everything. So let's see that. So we see that two things. One is the module S3 bucket. This is a AWS S3 bucket. It will be destroyed. And one more thing is that the public block access, this one also destroyed. So if we go back to our resources in the module section here, bucket, we see that we have created two resources and these two resources will be destroyed. So if everything is fine, it will show the gist of the plan here, that 0 to add, 0 to change, and 2 to destroy. If we see this one and if we give yes, so it will try to destroy it. I think as we already know that the bucket destroy takes some time. So if we still refresh this one, so the bucket is gone. That means it is destroyed. So Terraform actually used this destroy command and destroyed every resources from our environment. Now, if we come back to our Terraform TF state, we see that under resources section, there is none. As we have destroyed everything, so it is not managing any resources. And the serial also changed. This is a different serial number now. And the previous state has been backed up here. This is the serial number 3, that is the previous one. And everything, my two resources are here as a backup. But the current state is this one. And this one says that no resources are currently managed by Terraform. So this is the magic of Terraform. So in a nutshell, I hope this Terraform introduction video was very much informative for you. If you have any other thoughts or if you think that there are other way we can do it, please let me know in the comment section. How do you feel about this video and what do you want to know more about Terraform? I will make this Terraform series a bit vast. I will also come back with another version of Terraform state, how to manage it remotely and in secure way rather than doing it locally. This is not actually recommended. So in my next video, I will also show you how can we manage the Terraform state remotely. Also, a couple of other resources, AWS services we will create an entire project with Terraform, like the VPC, like the EC2 instances, like the route tables, NAT gateway, internet gateway, everything we will create from scratch. So please tune in. Those who have not subscribed, please subscribe to my channel for the latest update you will get. And other than that, please like, share, and subscribe, and the comment your thought in the comment section. I will be back with another exciting Terraform video, and I hope you like this video. Till then, take care. Goodbye.